Have you ever just looked up at the night sky and felt completely in awe? Well, get ready because that feeling is about to get a whole lot deeper. What if I told you that everything we can see out there, every star, every galaxy, all of it, is just a tiny, tiny fraction of what actually exists? Today we are going on a journey, a detective story really, through the history of cosmology, to figure out how we discovered that we know almost nothing about 95% of our own universe. It's a story about being wrong, about mind-bending scales, and about a mystery that just keeps getting bigger.
And you know what's wild? Is that this idea of a hidden universe, it's not new, not at all. We're talking way back in 1884, the physicist Lord Kelvin was doing the math on the mass of our galaxy. He looked at how fast stars were moving, and he realized the numbers just didn't add up. There had to be a huge number of dark bodies out there, pulling on things with their gravity. He had no idea how right he was.
So this is the big question we're tackling. How in the world did we go from thinking the universe was made of the stars we see in the sky to realizing that all that stuff is barely a rounding error in the cosmic budget? The answer is a wild ride of getting knocked off our pedestal again and again.
All right, so our story really starts with the first great cosmic reality check, the moment we realized planet Earth was not, in fact, the center of everything. For like over 1,000 years, everybody just accepted the geocentric model you see on the left. Earth is in the middle, and everything else, the sun, the planets, they all circle around us. And look, it makes sense, right? It feels like we're standing still. But explaining the actual movements of the planets got really complicated. The model on the right, the heliocentric one, was a much cleaner idea. The big headache for astronomers was this thing called retrograde motion. If you track a planet like Mars night after night, it seems to stop, move backward for a bit, and then go forward again. Weird, right? Well, in an Earth-centered model, you need these incredibly complex loop-the-loops to explain it. But Copernicus realized, hey, what if you just put the sun in the middle? Then that weird backward motion is just us on Earth, lapping the other planets in our own orbit. Simple, elegant. But here's the thing about big revolutionary ideas. They don't catch on overnight. I mean, look at this timeline. Copernicus publishes his work in 1543. Decades later, Galileo gets put on trial for defending it. It wasn't until the 1830s that we got the final definitive proof, and it took all the way until 1992 for the Catholic Church to formally say, okay, our bad, Galileo was right. Big shifts in how we see the universe are hard. They take time.
So, once we finally figured out the layout of our own solar system, the next question was obvious. Just how far away is everything else? How big is this place, really? To figure that out, astronomers came up with this brilliant method called stellar parallax. You can actually see it for yourself right now. Just hold your thumb out in front of you. Close your left eye and then your right. See how your thumb seems to jump against the background? That's parallax. Astronomers did the exact same thing, but on a cosmic scale. They'd measure a star's position in January, and then again 6 months later in July, when Earth is on the complete opposite side of the sun. That tiny little jump let them calculate the distance using basic trigonometry. And when they finally managed to measure that tiny shift in the 1830s, the results were just mind-blowing. The angles were so incredibly small, which meant the stars had to be trillions and trillions of miles away. In an instant, our idea of the universe just exploded. The space between the stars was revealed to be an emptiness more vast than anyone had ever imagined.
But you know how it goes. The better our tools get, the more precise our measurements become, and the weirder things start to look. The data started showing us things that, according to our understanding of the universe, just shouldn't be happening.
It really kicked off in the 1930s with an astronomer named Fritz Zwicky. He was studying this huge group of galaxies called the Coma Cluster, and he noticed something really strange. The galaxies were zipping around each other way too fast. So fast that the gravity from all the stars he could see shouldn't have been nearly strong enough to keep the cluster from just flying apart. He figured there must be some kind of invisible dunkel materia, German for dark matter, holding it all together.
Zwicky's idea was mostly ignored for decades, but then came the real smoking gun in the 1970s from the work of Vera Rubin and Ken Ford. They were measuring how fast spiral galaxies spin. Now, basic physics tells you that the stars on the outer edge should be moving much slower than the stars near the center. Just like in our solar system, Pluto moves way slower than Mercury. But that's not what they found. As you can see here, they found that the outer stars were moving just as fast as the inner ones. It made no sense. It completely broke the laws of gravity as we knew them.
The only way to make the math work was to bring back Zwicky's old idea. There had to be this massive, invisible halo of stuff surrounding the entire galaxy, providing a ton of extra gravity. And we call it dark matter, not because it's sinister or anything, but simply because it doesn't give off, reflect, or block light. We can't see it at all. We just know it's there because we can feel its pull.
Okay, so just as astronomers were trying to wrap their heads around this invisible matter making up most of the stuff in the universe, an even bigger shock was just around the corner. The universe wasn't just big and full of invisible stuff, it was also running away from us.
For decades, one of the biggest questions was whether the expansion of the universe was slowing down. Would gravity eventually win and pull everything back together in a big crunch? Well, in 1998, two separate teams found the answer by looking at exploding stars called Type 1a supernovae. These things are amazing because they're standard candles. They always explode with the same brightness. So if you see one, you know how bright it should be, and you can tell how far away it is. But when they looked at really distant ones, they were fainter than expected. There was only one possible and totally shocking conclusion. Those supernovae were farther away than they should be because the expansion of the universe itself is speeding up. Some mysterious repulsive force is pushing everything apart, overwhelming gravity on the largest scales. They gave this force a name: dark energy. And funny enough, Einstein had actually predicted something just like it, his cosmological constant, which he later called his biggest blunder. Well, it looks like he might have been right the first time.
So let's put all the pieces together. After centuries of chipping away at these cosmic mysteries, what's the final picture? What is our universe actually made of?
Well, here it is. This is our modern cosmic recipe, and it is absolutely wild. It turns out dark energy, that strange stuff accelerating the expansion, makes up a whopping 69% of the universe. Then you've got dark matter, the invisible glue holding galaxies together, making up another 26%, which leaves, well, not much for everything else.
Just 5%, that's it. Every star, every galaxy, every planet, every cloud of gas, you, me, everything we have ever seen or touched, it's all part of that little 5% sliver. We are not the main characters here. We're not even the supporting cast. We're the cosmic exception.
Now, I know you might be thinking, this all sounds a bit out there, like a wild guess, but it's not. This crazy recipe is confirmed by totally separate lines of evidence. We see its signature in the afterglow of the Big Bang, in the way gravity from massive clusters bends light, in the way galaxies clump together across the universe. They all point to the same bizarre conclusion. This quote really just nails it. This isn't just a science result, it's a fundamental change in how we see ourselves. First, Copernicus kicked us out of the center of the solar system, and now we've learned that we're not just off to the side, we're not even made of the main ingredients of the cosmos. It's the ultimate reality check.
So we've gone from thinking we were the center of everything to being a 5% minority in a universe dominated by forces we can't see and don't understand. Each major discovery has only revealed a deeper layer of our own ignorance. Which leaves us with the ultimate question, doesn't it? What are we missing now? What giant, universe-shattering truth is waiting just over the horizon, ready to rewrite everything we think we know, all over again?